Now we'll be doing some questions on scheme. Write a scheme function for the factorial. Example, the factorial of 5 can be taken as 5 into 4 into 3 into 2 into 1, or 5 into the factorial of 4. We can write it as define factorial x, condition equal x0 is 1, because we have taken the x equals 0 as the base case of our function, and then if x is equal 1 we are going to give the output as 1, else we have to multiply the x into the factorial of x minus 1. Now we'll see, this is the base case. We can stop the condition at this point, and this is the place where we have used recursion, factorial minus x1. Now we'll write a scheme function for the Fibonacci. This is the example of a Fibonacci series 1, 1, 2, 3, 5. This is the Fibonacci function. Define fib n, condition, this is the base case, n equals 1, we are going to give the output as 1, and then Fibonacci n minus 1 plus Fibonacci n minus 2. Now we'll write a scheme function called sum to compute the addition of numbers 1 to n. When we give sum 5, we should get the output as 15, because the addition of numbers 1 to 5 is 15. To write the sum function, we have to write define sum lambda value, condition, the base case is that value equal 1 returns 1, else we should add value to the previous sum of the value minus 1. In here we have used recursion, so we can easily add the value to the previous sum of the value minus 1. Now we'll move on to the compare function. We can give as compare xy. The compare function should compare numeric types of atoms and return the appropriate phase. Define compare xy. We have used the condition function here, and less than xy should display x is less than y if that statement is true. Greater than xy should display x is greater than y if that statement is true, else if both are incorrect it should display x and y are equal. Now we'll write a function, exponential function in scheme. In here 2 is x and y is 3. Define, the function name is exp, xy, the true atoms. Condition, y equals 1 is x and y equals 0 is 1. Else, if both statements are wrong, we should return x into the exponential of the y minus 1 value. Now we'll write a function that will get the sum of a list. Define sum list. We are using the if condition here. If the list is null, we return 0, else we add the car of the list to the sum of the CDR list. Here we have used recursion and get the sum of the rest of the list when the car is removed. Now we'll define a function that return list of numbers, squares of all numbers in the list. Define my square number list. If the list is null, we return an empty list. Else, we use the cons function to combine the two lists. In the first list, we multiply the car of the list from the car itself and combine it to the CDR list return from the my square numbers function. In here we have used recursion to get the CDR lists squares. So finally we add the first car to the CDR list square numbers. Now we'll write a function called member that takes an atom and a simple list, returns true if the atom is in the list, otherwise returns false. We use member for this function name as scheme is a simple function language. Define member, we give the atom and the list. If the list is null, we return false. If the atom is equal to the car of the list, we return true. Otherwise, if both statements are false, we are going to return atom and the CDR list to the member function. Now we'll define a function named add1nums which returns a new list of numbers containing all the numbers of the original list increased by 1 and all the non-numbers will be removed. In here we assume we are taking a function called number p which detects numbers and non-numbers. This is the function we have written for this question. First we give the function names as add1nums. The parameter name is list. First we check if the list is null. If the list is null, we can send an empty list, and we are using const function here, so we are going to give a second condition. In the second condition we are checking that if the car list is a number, so we are going to send the car list to the number p function. If it is true, we are using cons to combine two lists. The first list is the car incremented by 1 and the second list is the CDR list recursively returned from the add1nums function. In the add1nums function, in here we are returning the CDR list backwards, so we'll get an empty list and at the end, and then we can combine it to the car list. Both statements are false, we will go to the else condition and then we will send the CDR list to the add1nums function recursively. Now we'll see how to define the length function to get the length of a list. In here we are giving a list with 4 atoms, so we'll get the output of 4. Now we'll see how we have written the function. First we define the function, give the function name as length, and the parameter we are passing to the function list. In here we are using the const function. The first condition is that if the list is null, we are returning 0. Else, if the condition is false, we are going to increment the previously returned value of length by 1. So we are also using recursion here. We are recursively sending the CDR list to the length function and get the increased value here, and we will add 1 to it and return as the length. Now we'll write a recursive function to return the last item of a given list. The hint is that we can use the length function to define this function. Now we'll see how we have written this function. We give the function name as last. We are giving a list, so we are giving the parameter name as list. In here we are using the const function, so the base case is that if the length list returns 1, we are going to check if it is equal to 1, and if it is equal to 1, we are going to send the car list. Else, if this statement is false, we are going to send the CDR list recursively to the last function.